Hello, this is Mr. Beckstrom again, and we're going to talk about Chapter 5, Section 3. We're going to do some more right triangles. This time we're going to solve for an unknown side or acute angle. Alright, so let's talk about a couple of different things here. So first of all, when we're solving right triangles, we're going to be talking about 6 main parts of them. The 3 angles and the 3 sides. The 3 angles can be classified into one right or 90-degree angle and 2 acute angles. Remember, acute angles are angles that are strictly less than 90 degrees. And then we also have 3 sides, which include the 2 legs, which are both adjacent to the 90-degree angle, and the hypotenuse, which is opposite the 90-degree angle, which is also the longest side. So we can use trigonometric ratios to find unknown sides and acute angles of right triangles if we know either of these combinations, if we know either the length of one side and one of the measures of the acute angle, or if we know the length of 2 sides. And the way that we do this is, if you remember from our previous section, we looked at 3 different trigonometric functions, the sine, cosine, and tangent, and each one of those, depending on which acute angle we're talking about, is defined as the ratio of the opposite side or some side over another side. So the sine is the opposite side over the hypotenuse, the cosine is the adjacent side over the hypotenuse, and the tangent is the opposite side over the adjacent side. And if you remember, we talked about Chief SOHCAHTOA, S-O-H, so that's S-O-H-C-A-H-T-O-A. Alright, so let's go ahead and just jump into an example here, see what we're talking about. So here I'm given a triangle, I'm given one acute angle, and I'm given one side, and they're asking me to find the 2 other sides. So I can't use the Pythagorean theorem in this case, because in order to use that I would need at least 2 of the sides. But since I'm given one of the acute angles, I can use one of my trigonometric ratios. So think about it for a second, and then we'll talk about it. If you want to pause here, you can. Alright, so they give us this angle B here, and what information do we want and what information do we have? Well, we have the measure of B, and we have the opposite side of B, so I want to use one of my 3 formulas that have opposite in it. So right now it's either going to be the sine or the tangent. And then let's say I want to find A first. Well, A is the adjacent side to B, so that would be the opposite that we have and the adjacent that we are trying to find. So which one is that? Which of these 3 trig functions uses both the opposite and the adjacent? Yes, so that would be the tangent. So we're going to use that one to solve our problem. One thing we can do is, since we already know 2 of the angles, the 90 and the 30, we can come up with the last angle, which may help us, it may not, but it's nice to do that. So this angle A would be 60. And then we're going to use that trig formula with the opposite and the adjacent in it, the tangent, and we set it up right here. Let me go ahead and hide my portrait, so hopefully you can see this now. So this is the tangent of A is equal to the opposite side over the adjacent side. So the tangent of 30 degrees, because this is the angle we're talking about, is equal to the opposite side, which is 4, over the adjacent side, which is A. Then we can multiply both sides by A to get A times the tangent of 30 is equal to 4. And then we can divide both sides by the tangent of 30 to get A is equal to 4 over tangent of 30, which is 4 square roots of 3, or approximately 6.9. Alright, so let's go back to this, and let's take a look at another example. Oh, actually we still need to find our C. So if we're still using this angle B, we could have used this angle A if we wanted to, but let's keep using this angle B. If we're still using that and we want to find C, well, the 2 sides that are in play, we could actually use this one now that we know it, but let's go ahead and keep using this opposite side. So we're going to need a formula with both the opposite in it and the hypotenuse. And once again, that's going to be the sine function. Since sine of some angle is the opposite side over the hypotenuse, we just plug it in, and just like we did with the last one, we can solve for that. Now multiply both sides by c, and then divide both sides by the sine of 30, and we should get 8. If we put it into our calculator correctly, 4 over the sine of 30, make sure your calculator is in the degree mode, and should come out right. Alright, so let's take a look at one last example here. Well, actually, I'm sorry. We're going to do 2 more examples. Alright, so this one here is we want to find the measure of angle A. So we don't know what this angle is here, but we have 2 of the sides. And if you remember from the beginning, we said that if we had 2 of the sides, then we could actually find all of the angles. Well, we know this one here is 90 degrees. So if we're looking at this angle here, we need the opposite and the adjacent. So which of our formulas uses that opposite and adjacent? And we already said it's tangent. So we're going to set up the tangent of A is equal to opposite over adjacent. We're going to put the 5 centimeters for the opposite side and the 12 centimeters for the adjacent side. And remember, when we're solving for the angle, the measure of the angle, we use the inverse of that function. So basically we multiply both sides by the inverse tangent, which just gets A on the left and the inverse tangent of 5 over 12 on the right. And we plug that in and we get about 22.62 degrees. So that would be our angle A. So hopefully you were able to get that. And then let's look at a more real world type question. So here they're asking us to find the length of the rafter shown. That would be this L here, round to the nearest inch. Well, we know that we basically have a right triangle that's formed here with the height, because the height meets the base at a 90-degree angle. And we know what? We know one of the acute angles and we know one of the sides. So once again, we're just going to set up a ratio, a trig ratio. If we're using this angle here, we have the opposite side and we want the hypotenuse. So that would be, that's right, the sine function. So we're going to use the sine function to do it. But notice that they give us our height in feet and inches. So it's important to either convert it to feet with a decimal, which would be 12.75, or to inches, which we're going to do in this case. So 12 feet and 9 inches. Well, 12 feet is just 12 times 12, which is 144, plus the 9. It's going to give us 153 inches. So we're going to convert this one to inches. And then we just plug all our values in. So the sine of 37 degrees is opposite over hypotenuse, which is 153 over L. Multiply both sides by L, and then divide both sides by the sine of 37. Put it in your calculator, and you should get about 254 inches. Alright, so try some of the practice problems in the book and on the homework. And please let me know if you have any questions, and I look forward to our next lesson. Thank you.